Okay, so we were working from the equation to the drawing. So now let's go the other way and write an equation for the hyperbola that we're looking at. So I see that example A, the hyperbola is cutting through the y-axis. So I know the y term comes first. So I know I have y squared and x squared, and a minus because it's the hyperbola, and then equals 1. So then I look at how far is it from the center to the vertex, and it's 1. So it's up 1 and down 1. So under the y will be 1 squared. Well, and then I can see the slope of the asymptote is 1. So that means to make this diagonal, we went up 1 over 1. So we can see that when they made the box, they went 1 in the x direction also. So we would write this equation as y squared minus x squared equal 1 because we don't write divided by 1 since it doesn't change anything. Okay, so let's look at the second example. And here I'm cutting through the x-axis, so I know I'm going to have the x squared term first, minus, then the y squared term, and equals 1. So I write the part I know right off. So from the center to the vertex in the x direction is a distance of 2. So under x squared goes 2 squared. Then the slope is 2. So we went up 1, 2, 3, 4 over 2 to get that slope of 2. So in the y direction, we went a distance of 4. So we need to divide the y squared by 4 squared. So your final answer would be x squared over 4 minus y squared over 16 equals 1. So now we're going to let the center be anywhere else but the origin at h comma k. And this is going to remind you a lot of the circle equation where we had x minus h quantity squared plus y minus k quantity squared equals r squared. That was for the circle. Well, we're still going to have x minus h and y minus k. So these are not functions, and the y direction behaves in a geometric way and not in a function sort of transformation way. So let's see if we can find an equation for this hyperbola that has a center at 1, 4. And I make the C for the center kind of curly just so I can see the difference between the lowercase c, that's the distance from center to focus, and the center. So then we have a focus at -2, 4. So we can already tell the transverse axis is going to be horizontal because the center, focus, and vertex all have to line up on the same line. So this is a focus. And then there's a vertex at 0, 4. So that's a vertex. So because of symmetry, we know we also have another vertex at 2, 4 from the symmetry. And we know we have another focus at 4, 4. So mirror image focus points and mirror image vertex points. Okay, so we know the transverse axis is horizontal. So that means the hyperbola opens right, left, and the x term is first. So now I'm going to leave space to put my shift in there. So this is my kind of bare bones. I don't quite know what's going on exactly yet. And then let me fill in. So it's x minus 1 quantity squared, since the center has an x coordinate of 1, and y minus 4 quantity squared, and that's what shifts the center up 4. Okay, so now we know in the x direction, from the center to the vertex is a distance of 1. So there'd be a 1 squared. And then we need to think about what else we know. So we can see that the distance from the center to the focus is 3. Well, the distance from the center to the focus is little c. So if little c equals 3, then little c squared equals 9. So let's give a name to this second denominator and say we know that the sum of the denominators has to equal the little c squared. So I know b squared has to equal 8. So that means b equals plus or minus 2 root 2, which is a little less than 3. So in the y direction, from the center, I need to go a little less than 3. And this distance is actually 2 root 2. So we know what the b squared needs to be. It's 8. And now we can draw our box where the vertices are on 2 sides of the rectangle and the red dots are in the middle of the other 2 sides. So we can see where the asymptotes need to go. And so we can draw the hyperbola touching the vertex and approaching the asymptote. And then we'd go back and erase this denominator under the x minus 1 squared since we don't show dividing by 1. So this would be my final answer for my equation. Okay, so let's look at this one. This one's quite a bit trickier. So we have vertices at 1, -3, and 1, 1. So this is a vertex and a vertex. So we know that the center has to be midway in between because of the symmetry of the hyperbola. So we know that the center is going to be 1, -1. And we know that the transverse axis is vertical because of the way the vertex, center, vertex are aligned. That transverse axis has to be vertical. So that means the y squared term comes first. And in the y direction, I went up 2 and down 2. So under the y squared term is 2 squared. And we see where the center is. So we're going to have x minus the 1 for the shift in the x direction, and then y minus -1, which is y plus 1, for the shift in the x direction. Now comes the tricky part. We need this second denominator. So let's see, we have some more information here. And this is just something to notice. that I think is really interesting. This is the point-slope form of the equation of a line, where the point the line is going through is the center, 1 comma -1. So notice that you have y plus 1 both in the equation of the line and in the equation of the hyperbola. And you have x minus 1 in the equation of the line and in the equation of the hyperbola. Okay, so let's see if we can graph these lines, these asymptotes. I see that the point that's on the line is 1, -1, my center, and then my slope is 3/2. So to draw the line, I'm going to start at the center, go up 3 over 2, and draw a dot. And then we also know we have an asymptote of up 3 and backwards 2, and draw another dot. So now we can draw these asymptotes. But the box that we're interested in has to go through these vertices. And then they have to touch the box at the corners. Ideally, your box would look better than mine. So we can see how far up and down we needed to go to get the vertices. But now we need to figure out this distance right and left from the center. So we need to figure out what this point is on the line. And I can see that the y coordinate is going to be 1. So I want to know, when y equals 1, what is x? Because that's the thing I'm interested in, is this x amount. But when I do this calculation using the line, I'm going to get this whole x distance, because it's just going to give me the x coordinate, and then I'm going to have to figure out what that means in my picture. So let's look at the equation of the line. Y plus 1 equals 3/2 x minus 1. So when y is 1, I'll have 1 plus 1 equals 3/2 times x minus 1. So 2 equals 3/2 times x minus 1. Now you could either distribute or multiply by 2/3. I'm going to multiply by 2/3 and get 4/3 equals x minus 1. So when I add 1 to both sides, I'm going to get 7/3. So I'm going to add 3/3 to both sides. So this distance from the y-axis over to the green dot is a distance of 7/3. But we know the center is already over a distance of 1. So this green piece has to be 7/3 minus 1, which is 4/3. So to the right and the left, we went 4/3 in each direction. So under the x term goes 4/3 quantity squared. So this is our equation of our hyperbola. And then we can draw it because we have asymptotes and vertices. Asymptotes and vertices. There we go. So that was a very challenging one. So let's look at an equation where it's not quite set up in the standard form yet. So let's get that part done first, where we need to divide both sides by 9. and get x plus 4 quantity squared over 9 minus y minus 3 squared. And you can put over 1 if that helps you see what to do, but usually we don't write divide by 1. Okay, so let's draw what's going on. We have the center at -4, 3. So there's my center. In the x direction, I'm going to go 1, 2, 3 to the right, and 1, 2, 3 to the left. And then in the y direction, I'm going to go up 1 and down 1. And that helps me make my rectangular box. And I draw my diagonals. And these are my asymptotes. And I can see that my slope is up 1 over 3, so 1/3. But now the origin is not a point on this line, the center is. So the equations of the asymptotes, using the point slope form of the equation of the line, is y minus 3 equals plus or minus 1/3 times x plus 4. And you actually don't need these parentheses on the left. So y minus the y coordinate of the point I know, 3, equals plus or minus the slope of 1/3 times the x minus the -4 that I know is the point on the diagonal line. So we found our center, our transverse axis. We need to figure out which way it goes. So the x term is first. So with the basic hyperbola, when the x term is first and the centers of the origin, we see that it cuts through the x-axis. So we know it opens right-left. So the transverse axis is this line y equals 3. So y equals 3. Sorry, I'm not very good at erasing on here. Y equals 3. Then our vertices, because we know it's going to open right left, our vertices are the blue dots. So our vertices are going to be -1, 3, and -1, 2, 3, 4, 5, 6, 7, 3. So read those off the graph. I got my asymptotes. So I need my foci. So little c squared is the sum of the denominators, or 10. So c is plus or minus the square root of 10, which is a little bit more than 3. So I know the focus point is a little past the vertex. And this distance is square root of 10. So you actually can write the focus points as you start at the center with the x coordinate of -4, and you know you're going in the x direction, plus or minus square root of 10, and the 3, the y coordinate, is not changing. And then we can draw our graph, make sure it touches the blue dots, the vertices, and approaches the asymptotes. And there we go. Okay, so I'm going to pause again and make one more movie that's going to be this second example and the application problem.